Taylor.
And my name is Michelle.
And what are we here to talk about today, Michelle?
We're going to talk about liquid nitrogen.
Okay, nobody looked excited by that at all.
They might know what it is up there. Everybody else doesn't seem to, so
maybe they just don't know what it is.
Right. Well, you know what? Nitrogen is naturally a gas. How many of you guys have ever experienced nitrogen before?
No, put your hand down.
Hey, guess what? Everybody can raise your hand right now. Because as you take a nice deep breath in, 78% of what you just breathed in was nitrogen as a gas.
But wait, Michelle, we're here to talk about nitrogen as a liquid, not a gas, right?
Correct.
So how does that happen? That's a different state of matter.
Matter. Well, we should talk about matter because it matters.
It sure does.
So, do you guys know your states of matter? Okay, cool. What state of matter is an ice cube? Solid. And then, how do I get it? Well, the next state of matter is what? Liquid. So how do I get it from a solid to a liquid? What do I have to do to it?
Melt it.
I'll give it heat, right?
Heat,
okay. And then how do I go from a liquid to a gas? Add heat.
Okay.
Boil it. So we go from a solid to a liquid and a liquid to a gas, we add heat. So if nitrogen is naturally a gas, how do we get it to a liquid?
So you're saying, Michelle, we use heat to go from a liquid to a gas. So what do we have to do? Exact opposite, to go from a gas to a liquid.
Right. So we have to remove all of the heat and make it super cold. Now, does anybody know how cold water is when it turns into an ice cube?
What temperature water freezes at?
32 degrees Fahrenheit, that's right.
Should we get some guesses? Does anybody have a guess of how cold liquid nitrogen is? A hint, it is less than 32 degrees. What's your guess? 5 degrees, a great guess. What's your guess? You don't know? That's okay, I'll come back. What's your guess? 0, a great guess. What's your guess, sir? 300? Do you mean negative or positive? Positive, that's really hot. What's your guess right there? 25, good guess. Last one, what's your guess? 5 degrees. Well, you guys, liquid nitrogen is actually negative 320 degrees. It is 320 degrees below zero. So it's very, very, very cold. Because it is so cold, Michelle and I have to take some extra safety precautions to make sure that we can handle it safely. So what are some things Michelle has on? She's got some goggles. She's got gloves on her hands. We both have on long lab coats and closed-toed shoes to make sure that no skin touches the liquid nitrogen. Liquid nitrogen is so cold, if we touched it, our body would process it as heat and it would burn us. So we're extra careful, right, Michelle?
Exactly. Now, Taylor, I hear you like balloons.
I love balloons. It's always fun to have a good party with balloons.
Fantastic. Well, good. I want to try a little something. In fact, I want to have a little competition. You think you can help me out?
I would love to, yeah.
Fantastic. Now, we're going to see which one of us can blow up our balloon fastest. Now, how many of you guys think Taylor can do it?
Wow.
Could be the winner.
Okay, there we go.
All right. How many of you think that I can blow up my balloon the fastest?
All right, we're just about a tie.
All right, so give me a countdown. Here we go. In 3, 2, 1.
Michelle played a little trick on you.
I did play a little trick on you, but I like to do that. That's
It's
okay.
fun.
Taylor, do me a favor. Make sure that this balloon is a sound balloon. It sounds okay.
It is indeed a sound balloon. Yep.
Okay.
It's a beautiful red color.
Yep, beautiful red balloon. All right, there's no air coming out of this red balloon,
Is there any air coming out of this red balloon? There's not any air from this beautiful red balloon? No? Is it not? It's not red? It's white?
Oh, I thought it was yellow. Okay, well, I'll go with you guys. Oh, yeah, okay, okay. All right, so what do you guys think is going to happen when we put this very cold liquid nitrogen onto this balloon? What do you think is going to happen?
I know some people saying pop.
Pop? How many people think it's going to pop?
A lot of people think it's
Does
going to
anybody
pop.
else have a different idea?
Different idea? Different idea? Do you have a different idea?
So it's going to break down.
It's going to break? Yeah. Oh, good. That's an interesting guess. What's your guess? It's going to freeze.
Oh.
Excellent. Way back there in the black with the blue sleeves. It's going to pop. That's a good guess. Yes, yes, yes. All right. Last one right here. Yes.
It's going to stay the same.
It's going to stay the same. A good guess. Well, we have a lot of good educated guesses here, which
Right.
is another word for what? Hot.
hypothesis.
That's
Exactly. So since the hypothesis is something we can put to the test, let's put it to the test.
Let's do it. I'm
Here we go.
so excited to see what's going to happen. Maybe it'll actually change into a red balloon. This would be really cool to see. Oh, no, Michelle. Oh, there was a hole in it. That's okay. We have more balloons. We can blow up another one.
No, Taylor, we didn't actually poke a hole in the balloon.
We didn't?
No, not at all. Do you remember how earlier, just a minute ago, we were talking about how do we take a gas? What happens to it when it gets colder? It turns into a liquid. So that's what happened. The air that was inside of here, the air that I used to blow up this balloon earlier, got so cold it condensed and formed into a liquid, right? So it's like being cold. When you're cold outside, you get all nice.
Oh, yeah.
Exactly. So to prove that I didn't actually poke a hole in it, I'm going to pull the balloon out and I'm going to warm it up.
Oh, boy. No way! It looks like a brain. Wow.
So as I warm it back up, all the liquid that was inside here wanted to go back to being a gas. Gas has helped expand the balloon back out to its original size. What do you guys think?
Michelle,
Right.
that was so cool.
Thank you. Oh, I get it.
You get it cool?
Yeah.
Cold.
So,
No one laughed.
now, how many people outside have ever woken up and seen fog outside?
Oh, I love fun.
Right? Okay. And maybe it's pretty cloudy out there today, isn't it, with all the
It
rain?
is, yeah.
Do you guys think we can make a cloud inside this very room right here?
Whoa, but Michelle, we're indoors. We can't make a cloud indoors.
Oh, we totally can make a cloud indoors. You see this jar I have right here, this jug has water in it.
Right.
It also has something else called water vapor, right?
Michelle, I'm very skeptical.
Oh, well, there's moisture in the air, then we're going to do something pretty spectacular too. Okay, well, that's a not very good cloud. Should we make it bigger? Yeah! All right, good.
Oh, okay. I'm less skeptical now.
All right, so I'm condensing the particles inside here, all this moisture vapor with a little mixing.
Whoa!
With every good cloud comes a little bit of rain.
Of course, absolutely. Very true.
Right? So again, this is just condensed particles. So that water vapor that's in our air that we can see right now has been turned so cold that you can actually see the particles. Now, how many of us have gone outside in the wintertime and seen our own breath?
Ooh.
Well, I have another experiment we can do right here.
Oh, I'm excited.
You know what, Taylor? I have actually heard, yes, you've been studying to be a master chef.
Oh, I am, in fact, a very good chef.
Yes,
I am.
think you can handle this next one.
I think I will. I'll make my favorite. Oh, I actually specialize, Michelle, in cooking with liquid nitrogen.
No, get out of town.
It's true. It is true. It's very cool. I make a delicious meal called Dragon's Breath.
Ooh,
It's very, very cool. Now, the question you may be asking yourselves is, well, how can you cook with liquid nitrogen when you can't even touch liquid nitrogen? Are you guys asking yourselves that?
I am.
That's a great question. So, let's think about this. We cook with fire, right? Do we actually eat fire? No. We just use the fire to make the food warm, right? So I'm just going to use liquid nitrogen to make these graham crackers very, very, very cold.
Oh,
So Michelle, do you want to find some brave people who are willing to try the Dragon's Breath?
volunteers. So I need people that can listen very well. In fact, you know what? I'm going to go for a little bit older. If you are 7 years or older,
Good idea.
Just to get the safe side.
Bengali, you're not 7.
All right. 1. Do you listen really well? Okay. 2, 3, 4. 5.
You guys go stand on the yellow circle right there.
Yeah, come stand on the yellow circle for me.
Thank you.
6, 7, and 8. Okay, that's what I'm gonna pick. Okay, guys, come on down. All right. Do me a favor. Come stand over here. We're gonna make a line. So you're gonna be my line leader. Everybody make a line this way for me, real quick. Right over this way. There we go. All right. Fantastic. Okay, return and face the audience. So here's what we're going to do. Taylor's making these very, 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 very cold graham crackers, right? So we're going to come around and you're going to take a graham cracker. I want you to take it, and as soon as you get it in your hand, you're going to put it in your mouth, okay? And then you're going to chew, and you're going to keep chewing. Don't stop chewing, okay? All right? And I know your parents say to be polite, we should chew with our mouth closed. You don't have to do that this time, okay? You guys can chew with your mouth open, and we're gonna see what happens, all right? Are you guys all set? Now, it is safe, but you do have to keep chewing. I don't want it to stick into your tongue, okay?
Michelle, do you want to try when
I'll try to show you what it looks like. Here we go.
1, 2, 3.
Oh. Woo! Let that go. Okay. And she keeps doing it. There you go. Good job, buddy. There you go. Keep doing it. Woo! Right? So what's happening here is the same thing that happened with that cloud. The moisture in our mouth. The moisture in our mouths are actually getting condensed and turned into the same thing as fog. Nicely done, you guys. Let's give a nice big round of applause. Yeah, you guys can come back to the seats for me. That was fantastic. You almost got some rings. I like it. That was good.
Well, what a delicious part of the day.
Yeah. Now, we've just shown you some ways that it can actually change matter, right? But there's something else we can do. And we can talk about boiling points.
Oh, boiling water, yeah.
Yeah. So who out there likes tea?
I love tea.
How do we make tea?
Boil water.
We boil some water, right? So we take a teapot, just like this one,
There is a
just like our other one. Now, well, we're gonna use, no, it's right there. All right, just like that one over there. And we're gonna put, so normally we put water in here, right? We said we put water in here, we put it on the stove, we make it really hot. In fact, 212 degrees Fahrenheit in order for it to boil. Now, how do I know when my water's done?
It whistles.
There's some steam coming out. Yeah, what else? A whistling sound. Okay. So how many of you guys think we can take something super duper cold? I talked that water has to be super hot. And we can make that whistle. Do you guys think that's possible? Oh, you guys are super smart. Taylor puts the lid on it, and off we go. So, boiling point doesn't necessarily mean that something has to get hot.
No, not at all. To boil means it's just changing its state of matter. So we were talking about states of matter, right? So, it's becoming a liquid. It's a liquid originally because this is liquid nitrogen, and it's becoming a gas. It's expanding. When the gas expands and changes its state, it makes that pressure and makes it whistle the same way boiling water does.
Exactly. So, boiling points are different for every single thing. Now, we're also seeing something else happen here. We're starting to see some condensation happen on the outside. Again, that's that moisture on the outside. Turning so cold, it's freezing. Exactly, and turning into frost, which is like a solid. Now, this gives me an idea. So we're seeing that liquid nitrogen turns from a liquid to a gas very rapidly.
Very rapidly, yeah.
And then it expands pretty quickly.
It expands
that with the balloon.
And you know that gas takes up more volume than liquid does.
Exactly. So how many of you guys want to see me launch a rocket?
Me.
Okay, yeah. We can,
let's see, we can maybe launch the spoon?
No.
Could we launch, let's see, this inflated balloon?
No.
We can launch a rocket!
Yeah.
Bottle rocket.
yeah, so I'm going to use just a little bit of liquid nitrogen.
All right.
Put it into the bottle rocket, and we're going to see what happens.
All right, I'm excited.
Okay, here we go.
So Michelle is putting the liquid nitrogen into the bottle. The liquid nitrogen immediately begins to boil because it is touching room temperature. Because it's boiling, it's starting to expand and turn into a gas. Liquid nitrogen actually expands to 700 times its natural form when it warms up. I don't know about you guys, I definitely don't get 700 times bigger when I get warm. All right, she's putting it on. Every good rocket ship needs a good countdown, so let's count down from 5, 4, 3, 2, 1. Oh, we're gonna do it again.
Hang on a second.
Einstein didn't get it right the first time either, guys. We're all good.
You know what? Every good science experiment happens once. Is that true? No. Right? Every good science experiment happens more than once.
This is a great example of trial and error.
Exactly.
Oh, you are brave.
Yes. This is what. Whoops. This is what's called a dewar. It's what holds our liquid nitrogen and keeps it nice and cold. All right.
We're good.
Get just the right amount. Okay, let me put my gear back on again. It is one of those days today. All right, here we go.
In 5, 4, 3, 2, 1. Woo! Okay.
Sorry about that. You okay over there?
Thank you.
All right.
Look at how frosty that is, Michelle.
Yes.
Well, okay, I have a question, Michelle.
Yeah.
So the reason this shot up into the air was because you didn't totally cap it, you just corked it. So what do you think would happen if we were totally to shut this off while the gas was expanding?
It
It would
explodes.
explode, but I don't think we should do that with a bottle because it's plastic and this could hurt people.
Yeah, no, that's too dangerous. But we can make something else explode.
We can blow something up?
Yeah, you guys want to see us blow something up?
What can we blow up, Michelle?
Well, Taylor, I know we needed a little help earlier blowing up some balloons.
We could have the liquid nitrogen help us blow up the balloon.
Liquid nitrogen, yeah, that's right. So we're going to use this test tube over here and a balloon.
Oh boy, okay.
And we're going to use a little bit of liquid nitrogen. Here we go. So same thing. This time I'm not going to let all that gas escape like I did with the rocket. Here we go. Pour some liquid nitrogen.
So we'll immediately begin to see it boiling because it is room temperature. Looks just like boiling water. It's just very clear liquid, which you can see.
Kind of mad science-y. Now, I'm going to cover my ears because I've done this a lot. You may want to cover your ears too once I put the balloon on.
No, I'm not gonna.
Here we go. Putting the balloon on top of the test
Don't do
tube.
it, man. Don't do it.
Immediately it begins to expand, making the balloon blow up a little bit. We're going to speed it up using catalyst. Turn it over, get the liquid nitrogen moving around in the balloon. It's expanding, warming up any minute. The pressure is building. There we go. Now it looks like a
Me either.
Well, I always say it's best to end every show with a bang. So
That's right. So that's the end of our show, you guys. Thanks so much for coming. If you guys have any questions, my name is Michelle.
my name is Taylor.
Make sure you guys stick with your chaperones. Thanks for coming.
See you later.